Hi everyone, let's start. My name is Aniket Maurya. Today I am your host and speaker for this Pi and AI event. In this event, I will talk about generative adversarial networks, GANs. So I will show how you can generate fake images with DCGAN in PyTorch and PyTorch Lightning. So let's start without any delay. So what are GANs? Uh, GANs are generative adversarial networks that can learn to represent real data distribution and then can synthesize or generate data that is not in the real data set. So for example, you can train a DCGAN on celebrity image, face image, and then the GAN can generate fake celebrity image that does not exist in reality. So here are some pictures. You can see these pictures are generated by GANs over different point of time. This picture here is generated by a GAN network, style GAN in 2018. And you cannot differentiate whether this image is generated is fake or a real person. All these persons are does not exist in reality. These are fake images generated by different GAN networks. So you can see the GAN has the quality of GAN has improved a lot, and it has not been a decade. So a GAN is composed of two neural networks, a generator and a discriminator. Generator is a neural network that accepts a random normal noise as input, and then it can generate a fake image. Discriminator is like a general typical image classification neural network that accepts image as an input, and it predicts whether the image is real or fake. So in short, generator tries to fool the discriminator by generating realistic looking fake image, and the task of a discriminator is to detect whether the image was fake or not fake. Generators are the heart of generative adversarial networks. It is responsible for generating fake images and learning the real data distribution. This image is the DCGAN generator architecture. It is from the original DCGAN paper. So here in this paper, you can see the input is a 100-dimensional random noise, and this random noise is then transformed into a 4 into 4 height and width tensor with 124 channels. And as soon as you step forward, you can see the number of channel is uh, reduced by a factor of 2, 512, then 256 and 128. And you can also observe the height and width of the GAN kernel is doubled, multiplied by a factor of 2, then 4 to 8, then 8 to 16, 16 to 32, and 32 to 64. So in the last, an image of height and width 64 is generated with number of channels 3, that is for RGB, red, green, and blue. Discriminator is just a second. Yes, sorry. DCGAN is an example of a generative adversarial network. So DCGAN means deep convolutional generative neural adversarial neural network. So DCGAN was means in the DCGAN paper, the authors demonstrated. Let me show you DCGAN paper. So in the DCGAN paper, the authors experimented with different type of image, and they trained to generate fake celebrity image, fake room, bedroom, and hall image, and different type of. They experimented on different type of creating different kind of fake images. So DCGAN, after DCGAN, there were many new GAN architecture that were created, and the accuracy was has improved a lot from the DCGAN architecture. Okay, seems like my network is slow. So yeah, so in this paper, uh, you can see the authors have generated bedroom images, realistic looking bedroom images from this DCGAN architecture. And they also experimented with celebrity, with generating fake celebrity image. Yeah. So another thing from DCGAN they demonstrated was you can do vector arithmetic with the uh, with the uh, with the vector with the noise vector. So you can subtract smiling woman vector from neutral woman, and then you will get a neutral man. Then you can subtract the vector of man with glasses from vector man without glasses, and add woman without glasses. You will get a woman with glasses. So it, these kind of experiments were done in this paper. Okay. So continuing on the generator and discriminator. So generator learns to generate whether the image was generator learns the real data distribution and creates a fake, realistic looking fake image. On the other hand, discriminator is a typical similar to a typical neural network, image classification neural network, that detects whether the image was fake or real. Means that it classify image into different classes. Our class is real and fake. So this is the real data distribution, and this is the generated data distribution. So the discriminator want this both the distribution to as far as possible. On the other hand, the generator wants this distribution to come closer. How is the GAN trained? So both generator and discriminator are trained simultaneously. Weights of both generator and discriminator are means initialized from scratch, and the generator also never sees the real data set. It is discriminator that gives the feedback to the generator whether that you have generated a fake image or a real image. So what happens is uh, the noise vector is the noise vector is passed through the generator. The generator creates a fake image. This fake image is put into discriminator. uh, the real data set is also input into the discriminator, and the discriminator feedbacks the generator whether you have created a fake image or not. If the discriminator successfully detects that the image generated by generator was fake, then it penalizes the generator for that. So uh, as soon as slowly generator learns to create a realistic looking image, and the it becomes hard to for discriminator to detect whether the image is real or fake. As you can see in the first during the starting of the slide I shown you, those images were hard to tell whether they were real or fake. So this image is very hard to tell whether it is real or fake. So now let's start how I will show you how you can train and build a DCGAN neural network architecture with PyTorch and PyTorch Lightning. So first you have to install, let's see, is there any question? Okay, thank you, Suresh. If you have some question, then you guys can ping in chats. Okay, so first we install this PyTorch Lightning library. and then we import all the function and classes that we are going to use. And in this experiment, I am using this celeb-A dataset from Kaggle. You can check out about this in. You can check out this dataset on Kaggle. You can search celeb-A dataset. So to download this dataset into Google Colab or your laptop, you have to you can directly download as zip, or either you can copy your Kaggle JSON key and put it at this location. Then you can just call this method. Just call this CLI command Kaggle datasets download and the dataset path on Kaggle. So. So here are some training details from the paper. The images are scaled to be in range of -1 to 1, and the training was done with a mini batch size as 128, and the optimizer is used is Adam optimizer with a learning rate of 0.0002. So and also the weights are initialized with normal distribution with a mean of 0 and standard deviation of 0.02. Apart from this, these are the author guidelines. All the pooling layers are replaced with strided convolution. So in a neural network, convolutional neural network, you have convolutional block. After that, generally you put max pooling or average pooling. So they have not used pooling layer. Instead, they have used strided convolution. That is convolution with more than one stride. Also, there is no fully connected layer in the discriminator. And batch norm is used in both discriminator and the generator. And leaky ReLU is used in all the layers of discriminator with slope of 0.02, and ReLU activation is used for generator for all the layers except the last layer, which uses the tanh activation function. So in the from the last layer, we get output with in range of -1 to 1. Here I have initialized all these variables and question. What are the difference between PyTorch and PyTorch Lightning? Yeah, so okay, what is the difference in PyTorch and PyTorch Lightning? So PyTorch Lightning is built upon top of PyTorch. So if you have coded in PyTorch, then you don't have to learn a new framework or something. PyTorch Lightning basically removes all the boilerplate that you have to write again and again in each experiment of your machine learning or deep learning experiment. So you don't have to write a custom training loop again and again. You don't have to means do so much to include mixed precision support and means all. So basically PyTorch Lightning allows you or abstracts all the boilerplate from you, so you can focus on your research and experiment rather than engineering, rather than writing long codes each and every time. So it supports all these many things by default. So it has logging metrics and visualization. You can visualize with TensorBoard, and it has early stopping, model checkpoint. You don't have to write code for model checkpoint, which in plain PyTorch you will have to. So it, yeah. So PyTorch Lightning is just is written on top of PyTorch, and every code that is in PyTorch will run with PyTorch Lightning. I will show you how you can convert your PyTorch code into PyTorch Lightning. Uh, okay, so we were, yeah. So I have initialized all these variables from the paper. You can see the batch size is 128, noise dimension is 100, learning rate is 0.002, beta 1 and beta 2 is also set. And then I will define my data load, image data loader. So this is a PyTorch class named dataset. I have imported here on top from torch.utils.data import data loader dataset. Yes, I will share this notebook after this session. Also, you can go to my GitHub repository and here you can search PyTorch-GANs. In this, you will get this notebook. Yeah. So I have here created my data loader. And so I am loading each file, and then all you have to create a data loader is create a class and inherit the dataset class from PyTorch. Then you have to define two functions, len, which is length of your dataset, and get item, that is you enter the index and it should return image and label. Okay. Now let's create our generator. So, like I told, the GAN is created composed of generator and discriminator. The generator, to create the generator, we create a class named generator which inherits nn.module. We import from torch import nn, and we initialize it, and in the init function we input number of channels and the noise dimension. So our noise dimension is here 100 and input channel will be number 3. Okay. So the smallest unit of the generator is a con block with batch normalization layer and activation layer. So here you can see this is our smallest unit. This is our smallest unit. So first we will create the smallest unit in our GAN network. First, in the smallest unit, we have a transpose convolutional network. To create a con transpose layer, you have to do nn.con transpose 2D, enter the input number of channels, number of output channels, kernel size, and stride and padding. So all these things are similar to paper. Then we have this batch norm layer and activation function. So if the tanh is only present in the final layer, so I have created this condition here. If final layer, then I have included tanh, else not. So I have created this network generator, which has first input channels as 1024, then it is downsampled to 512, 256, 128. And in the last, it has 3 number of output channels. So after the generator is created, we create the discriminator, which is a usual image classification neural network, and it is also inspired from the paper. Also, this code is referenced from the original PyTorch repository. You can reference from there also. After you have created the generator and discriminator, this is the function to initialize all the weights with mean 0 and standard deviation of 0.02. Now we write the training loop. So if since I am using PyTorch Lightning, I won't have to write my own training loop. So let me show you what is the difference in PyTorch Lightning and PyTorch. So after I have built my generator and discriminator, if I am using PyTorch, then I will have to write so much lines of code. I have to uh, write back propagation by myself, means not myself. I have to call this backward function, which will back propagate, call back propagation. But if I am using PyTorch Lightning, all I have to do is create a class GAN. It will be inherit this lightning module pl.lightning. Then I will initialize this generator and discriminator object in the init function. And in the GAN we have two step function. One is discriminator and another is a generator. That is, our discriminator and generator will learn simultaneously. So a training step function is basically what the neural network will take as input and what it will return the loss. So our discriminator takes real image X and noise. So the fake image is created here from the generator. Generator takes the noise and creates this fake image. This fake image is then passed through the discriminator to create logits, and the loss function is called with the first both the real image and fake images are passed through the discriminator, and loss function is used to calculate the real loss and fake loss. So remember, okay, okay. So here in my GAN class, I have this self.gen, means self.generator. So I will pass my noise through this generator object and it will return me the fake images. Now I will pass this fake image through the discriminator, and the discriminator will output whether the image is real or fake. Now I will also pass real images in the discriminator and it will output whether the real image is real or fake. Okay. After this, I use the output from discriminator to calculate loss. So the real logits should be equal to 1 and the fake logits should be equal to 0. So we will create our y ground truth like this, toss.ones like real logits. What it does is it will take the dimension of this real logits and create a same dimension matrix with all the value as 1. Similarly, all the values as 0 will be created here. Then we will take the average of fake loss and real loss, and we will simply return this discriminator loss. You can also create logs in your this code just by using self.log and write the whatever you want to write, and then this disk loss. Similarly, in the generator step, the noise is passed through the generator, the fake image is created, and this fake image is then passed through the discriminator to create the fake logits. Now this fake logits are used to create the loss, and this loss is returned. So uh, basically, if I summarize this, there are two step function: generator step function and discriminator step function. Both take your real image and fake image and returns the loss. In the training step, here you can pass batch, which is your data of the particular batch. Then you can know your batch index. Suppose you have 100 data, 100 length of data set is 100, and each batch size is 10. Then you will have 10 total number of index, 0 to 9. So this is optimizer index, since we have two optimizers, one is for generator and one is for discriminator. So here, first, if the optimizer index is 0, here this optimizer is coming from this configure optimizer function. So you have to define your optimizer here, opt-g, opt-d for discriminator and generator, and I have written both of this as list. So when the index is 0, then I will have this generator optimizer, and I call generator step. Similarly, on the discriminator optimizer, I call this discriminator step, and I return the loss. Then I create the GAN model and use this pl.trainer, and then just call trainer.fit model model comma dl. Dl is my data loader, and you can see it is just 4 epoch. So as the number of epoch increases, these are the generated images. In the first image, you can see it is just some random noise. As soon as epoch increases, the quality will improve. So yeah, you can use this notebook and train this for 50 or 100 epochs maybe, and try to check how the generated image looks like. Okay. So that's it. This is how you can create, build, and train the DCGAN network using PyTorch and PyTorch Lightning. Any question? If someone have any question, then they can ping here. Anyone have any question? Okay, so you can follow me on Twitter. My user ID is Aniket Maurya, and on LinkedIn also. Is GAN based on the same principle as DCGAN? Yeah, so DCGAN is based on GAN. So DCGAN is an example of GAN. DCGAN means deep convolutional generative adversarial network. That is a generative adversarial network GAN, which can be used to generate fake images. It is an example of GAN, DCGAN. Any more question? Okay, after this event, you will receive an email for survey. You can complete that survey and you will get a discount on Coursera courses. So I will request you to complete the survey. Also, to learn more about GANs, you can join this Coursera course on, there is a specialization by Sharon Zhou, who is from Stanford University. and the name of the specialization is GAN specialization. You can enroll there, so you can use this coupon as well to enroll in the course.